Just started. Anybody? We are in week number 11. Yes or no?
Yes, sir.
Yeah, so we are in week number 11. Okay. So, as per our outline, we are in line with the outline. Let me share. I think I should share some videos regarding the algorithm. Before going to video, I just give some introduction about the algorithms. Okay. Okay, here it is. Uh, Parallel algorithms. You will see this is very important chapter because you will get at least 15 marks question from this part 1 and part 2. Okay. We call it parallel algorithms. Okay. In this chapter, actually, we will see the basic graph theory. Okay, the basic graph theory. So the topic overview is the definitions and representation, minimum spanning tree. We'll see the definition of graph, types of graphs, vertices, okay, their adjacency graph, many things. And then we have MST, minimum spanning tree, Prince algorithm, Kushkal algorithm, and single source shortest path we call Dijkstra algorithm. Okay, so these are the algorithms we will see in this chapter. So first I will give you some introduction, then we will move towards a YouTube video. So it will be very, very easy. So I will share the YouTube video also. So it means that by watching the video, you will be able to see the working of each and every algorithms graphically. And I will give some animation. So graphically and animations, it will be easy for you. Okay. This is topic overview that we have few algorithms. We'll see one by one. But before going to this algorithm, what does it mean, how it works, what is the purpose of algorithm, the definition, everything, the explanation we will see later. But now we will see the definition and representation. Okay, this is we have graph. Okay, what is graph? Okay, in a graph we have two things, nodes and the vertex. Okay, so we have two types of main graph, undirected graph and directed graph. Two types of graph, undirected graph and directed graph. What do you mean by undirected graph? So an undirected graph, basically we call it G mean graph, is a pair of V comma E. V comma E means simply V is the finite set of point called vertices, called vertices. And E is the finite set of edges. Okay, so we have in a graph, we have two things normally, vertices and edges. Okay, but in undirected graph, what we have finite set of point. Finite means limited. We can count finite set of point called vertices, which is V, and E is the edges. So an edge, small e, belongs to capital E, is an unordered pair VW comma V, where VU or WV belongs to V, because V is the finite set of points we call vertices. We'll see next slide that how we represent the graph. Okay, undirected and directed graph. So in directed graph, the edge E is an ordered pair of U comma V, and edge U comma V is incident from vertex U and is incident to vertex V. It means that apart from a vertex V to A, vertex U is a sequence 1, 2, 3, 4, 5, 6 up to N of vertices V0, V, VKU. We will see next how does it mean. So the length of the path is defined as a number of edges in path. So when you see the representation, it will be very, very, very easy for you to see. Okay, now see. Yes, definition and representation of number A is the undirected graph and number B is the direct graph. How you distinguish? B, you have a direction. A, there is no direction. Okay, so you can see the difference between A and B, the undirected graph and direct graph. Okay, so in direct graph there is a arrow indication, and undirected graph there is no arrow indication in undirected graph. But how how we read this, like here, in direct graph, it's very easy to read. It's very easy to see the nodes. Okay, but here you have to follow start till end. Start till end. In and diagram, you have to follow start till end. How? Machamana. Here, yes. See here. Here you can see a path is simple if all of its vertices are distinct. There is no more than one edge connecting any pair of vertices. Contains no loop. Mean if you have multiple vertices, we call loop. I will show you the video. You will see how loops occur. Loop mean within like A to B, there is a more path. If you have more than one path, we call loop. Okay. So apart from a cycle, if its starting and ending vertex are same, it's a starting and ending vertex are we call cycle. Like start from 1 to 3, 1, 2, and 3, we call cycle. Okay, we see now in figure 10.1, which is data graph, which is simple cycle. How simple cycle? 1, 5, 6, 4, 1. Now see this data graph 1, 5, 6, 4, 1. How? 1 arrow is going to 5 and arrow is going to 6, and also we have two options, 3 or 4. Okay, we will take one cycle only. 4 and 1. 1, 5, 6, 4, 1. Understand? From I am just talking about the B, figure B. If I take only one cycle, how is one cycle? From 1, then 5, then 6, then 4, and then 1. I can go like also like this 1, 5, 6, 3, 1. Can understand? And I can go like this 1, 5, 2, 1. Yes, all we call cycle. The completion from start to end, start some by end, we call cycle. Very simple. 1, 5, 6, 4. Direct, simple cycle. And here undirected, no simple cycle. There is no simple cycle in undirected graph because it contains loop. How? Because you can see here. See 1, 2, 5, 3, 6, 5, 4, 1. See 1, 2, 5, 3, 6, and 5, and then 4, and then 1. Understand? This is basically we call undirected, no simple cycle because it contains loop 5, 3, and 6, 5. You can see here 5, 3, and 6, 5. This is a loop. This is we call loop. This is we call loop. 5, 3, and then 6 and 5 here. This is we call loop. Okay, so see here 1, 3, 5, again 3 and 6 and 5 again. So because there is a loop, that's why we have to consider this loop also. Okay, a graph with no cycle is called acyclic. A graph with no cycle is called acyclic. These are the basic definition. After watching the video, the concept will clear about direct graph, indirect graph, looping. Okay, and this is a complete graph is a graph in which each pair of vertices is adjacent. Like here, below is the complete graph. Okay, below is the complete graph because here each and every pair of vertices is adjacent. It means that every pair of vertices is connected by an edge. This is complete graph. Okay, so definition and representation and undirected graph is connected if each and every pair of vertices is connected by a path. A forest is an acyclic graph and a tree is a connected acyclic graph. We'll see this later. A graph has weights associated with each edge is called a weightage graph. Weight means if I go to A to B here, for example, 5 to 4 or 1 to 3, so there is some weight between 1 and 3, between 3 and 5, 5 and 2, 2 and 1. We call its weight. We call its weight. Weight is a number, or we can say weight is a cost. The cost from 1 to 3, the cost from traveling to 3 to 5, the cost from traveling to 5 to 2, the cost from traveling to 2 to 1, we call weight. We call weight. Okay. So graph can be represented by their adjacency matrix. Now we will do some practical. Now it will be easy for you to understand how graph can be represented by their adjacency matrix. Adjacency matrices have a value Aij is equal to I, capital I. If nodes I and J share an edge 0, otherwise. In this case of a weight graph, so I am going towards straight towards the example. Very simple here. Okay, this is the definition of undirected graph and its adjacency matrix. How we write the adjacency matrix of undirected graph. So number one, you will see the node. How many nodes here? 1, 2, 3, 4, 5. We have 5 nodes. It means that your matrix will be 5 by 5. Very simple. First of all, how you write the adjacency matrix. So in matrix, we have row and column. So how you decide how many rows and how many columns? Very, very simple. You just see the nodes. We have only 5 nodes here. 1, 2, 3, 4, 5. So it means that it will be 5 into 5. 5 cross 5. 5 by 5. 5 cross 5. 5 into 5. So our matrix will be 5 into 5. Okay. Now we will have to write the corresponding number. How we write the corresponding number? Very simple. For example, if you see 1, start from 1. Start from 1. So how many nodes are directly connected with 1? Yes, how many? How many nodes are directly connected with node 1? Yes. Yes, please. Are you sleeping?
One.
Only 1. Good. Bagos. Good boy. So see, you are saying that only 1. So how we write in the matrix? With 1. With 1. And the number is 2. Number is 2. So all is 0. 1 is also 0 because we are at 1. And 2 will be 1. 3, 4, 5 will be 0. The position 2 will be 1. The position 2 will be 1 and all will be 0. Okay. Now 2. For 2 node, how many nodes are directly connected with 2?
3.
3. Very good. So see here, 1, 3 and 5. 1, 3 and 5 are the nodes that are directly connected with 2. So very simple. Here 1 will be 1 position 1, and 3 will be 1, and 5 will be 1, rest 0. Very simple. Okay. So how many nodes are connected with 3?
2.
2 only. Only 2. 2 and 5. So we will write 1 in position 2 and 5 and rest 0. So here you can see 2 and 5 is 1 and all is 0. And likewise with 5 how many? 1, 2 and 3. Okay. It means 3, 2, 4. So in position number, sorry, 5, here 1, 2, 3, in position number 5, we can mention here 2, 3 and 4. And what about 4? Only 1. 4, only 1, which is 5. So here all 0 and just 5 location will be 1. Faham, understand how you write the adjacency matrix? Understand? Very, very simple. Maybe you will see this question in your final exam. I will give you some matrix and you have to write the adjacency graph. Yes, understand or not? I will explain further. I can explain again. Yes, who will explain this? Okay, it's very easy. Okay, so now this is basically an undirected graph and its adjacency matrix. Very simple. We have graph which is undirected. How you know? Because there is no arrow. There is no arrow. Okay, we know. And here, number 2, an undirected graph and its adjacency list representation. This is adjacency list, like link list, like link list, link. We have to make a link. Okay. Upper one is adjacency matrix and the below one is adjacency list representation, like a linked list. Okay, how? Same graph, 1 2 3 4 5. So 1 is linked with only 2, so 1 and 2, and we the second box we write the this correction, only 2 only, it means only 2. And then with 2, 1, 3 and 5, after 5 we write like finish line. We call finish line, or we can disconnect. Okay, or we can say end. We can say end. After 5, end. And with 3 only 2 and 5. After 2, 5 and then end. With 4 only 5, only 1, which is 5 and then end. In 5, 2, 3 and 4. After 4, end. Very simple. We can write the adjacency list and the adjacency matrix. This is important. Definitions are not important. Definitions for your understanding, but this is the main thing that you should know. And the purpose for this exercise is that you should know how you read the graph, how you see the cycle, how you go, like for example here, like 1 4 6 3 1. Okay, or you have different, like for example 1 5 2 1, like this. And here you have to complete the loop, 1 2 3 1 2 5 3 6, again 5 4 and 1, like this. Okay, just to see how to read the graph. And this is basically uh, the example of undirected graph with its adjacency matrix and undirected graph and its adjacency list representation. Very, very simple. Understand? Yes. Okay, I'm going further.
Sir,
Yes, yes.
for the list, do we have to susun in ascending order?
Yes, yes. You have to follow the ascending order. It's good. Otherwise,
Uh,
no need. You can write any of the edge, no issue. But it's good to write the ascending order.
okay, thank you, sir.
Yes, it's good to write. Otherwise, no need. You can go like 1, 2, or is there any other number? You will consider that. For example, here start from 7, start from 4. So you have to write that particular number.
So the slash is
Termination, the
representing the
termination
ending.
of end.
Okay, okay,
The
okay.
slash is denoted by end, like as an end. Okay, and you have to follow the same number. Like this is example 1, 2, 3 maximum. For example, I will give number 1 will be 7, 2 will be 5, 3 will be 8, 4 will be 9, 5 will be 10. So you have to follow the same pattern. And the most important is that you have to write the adjacency list or adjacency matrix of each and every node. So there is not like you have to follow the ascending order. You can write it in any order. The most important is to show the adjacency list. How many links, how many nodes are adjacent with 1, 2, 3, 4, 5, and so on. Okay, now we'll see minimum spanning tree. What is minimum spanning tree? Basically, if we see the purpose of this, that why we need minimum spanning tree, why we need for this, why we go for this. So, like for example, if you see in the network, basically, in the network, we have to follow the minimum links, the nearest route, the shortest route. Okay, understand? What we have to do? We have to follow the simplest and shortest route. Understand why we have route for example 1, 3, 8, 7, 6, 5 go to their side, this side, this side. So we want to minimize the turn. We have to minimize the total cost. We have to minimize the total distance. Understand? That's why we need, like we are saying that this is the minimum spanning tree or MST. Okay, MST is a way of connecting group of points using the cheapest or shortest possible path without any loop, without any loop. Like if I give the example of the networks, think of it like planning a fiber optic cable network for a neighborhood. You want to make sure every house is connected to the internet, but you want to use the least amount of cable. We want to use the least amount of cable. So what does it mean? Why you want this? Because you want to save money. We want to save cost. This is we call minimum spanning tree. Okay, so there are some points that you have to keep in mind before going to minimum spanning tree. A spanning tree is an undivided graph G, is a subgraph of G, that is tree containing all the vertex of G. A spanning tree of, and definitely it will contain all. In a weight graph, the weight of a subgraph is a sum of weights of edges in the subgraph. We'll see this next. And the MST, The minimum spanning tree for a weighted under graph is a spanning tree with minimum weight. With minimum weight. We'll see this in YouTube video. Okay, see the example. This is example. We have undivided graph, and this is other is the second one is the minimum spanning tree. Minimum spanning tree. See, we omit the loops. We omit the other alternate paths. We consider only this path that having a minimum cost. Understand? Here, as you can see, the number of nodes are same. Okay. The number of nodes are same 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. But which thing is different? The difference is the edges. We remove the irrelevant edges having more cost. We only choose the least cost. This is basically we call MST. Yes, I already given you the example of network. Set in a computer network or in a network, what we have to do, why we go for it, because we want to save the cost, because we want to use the least amount of cables. Okay, spanning mean it must connect every single point in a group. It cannot have any loops, cycle. You only need one path to get point A to B. Minimum means what we call minimum. Out of all the ways to connect the points, this one has the lowest total cost. Lowest total cost means distance, weight, and price. Okay, again, I can give you an example for this. Imagine 3 houses A, B, and C. We have 3 houses A, B, and C that need to connect by roads. So the distance between our A to B is 5 miles, B to C is 10 miles, A to C is 2 miles. So how we built the MST? MST will be like this. Like start from shortest road, connect A to C, which is 2 miles. And then find the next shortest route, which is 5 miles, A to B. And we stop. Now every house is connected. A to C and A to B. So total cost will be 7 mile. 7 mile. So anyway, there are a lot of real world examples for MST. In electric grids mean wiring a house or a city with least amount of wire. Computer networks, connecting servers efficiently. Cluster analysis, grouping similar data point in machine learning. So anyway, this is basically the simple example for the MST. Now I will show you something, and you will understand in a better way. Okay. Okay, we start from Prim's algorithm. Prim's Kruskals, disaster 1, disaster 2. Let me show the YouTube video, very simple. Today we'll see only one video. Okay, Kruskal is okay. Okay, wait. Kruskal. 49 students. Okay, so just I will show you only one video, and next we have 3 weeks more, 12 and 13, 2 weeks. Within 2 weeks I will complete all the 7 or 6 algorithms. Very simple, very easy. So let's see algorithm. Okay, first I want to share in our group. This is B. Okay, I already share in the group, and now I'm sharing here. This is algorithm number 1. Find minimum tree using Kruskal's algorithm. Okay, very easy. Just 4-minute video. Just 4 minutes video. Okay, let me start this video. Okay, so here before we start, I will request you to take some paper and pen and solve this problem with me. This will help you in understanding the algorithm better. So the number 1 algorithm is Kruskal's algorithm. Very simple, very easy. You will see this video later also. So first of all, you have to keep something in your mind that here, this is our graph. This is our graph. How many nodes we have? A, B, C, D, and we have some edges. So here you can see we have some loop and we have some duplicate links. How we have to do? We have to remove first. So see here, what? Okay, this represent an edge, and this represent a vertex or a node. A, B, C, D is a vertex, and this represent is an edge. Okay, we understand, we know this. And this represent the weight of the edge, like 5, 3, 1, 2 is the weight of the edge, the cost of the edge or weight of the edge. Okay. Okay. So step number 1 is remove all the loops. So you can see how many loops we have. What is loop? Loop means any edge that start and ends at the same vertex is called loop. How many loops we have here? Yes. Yes, how many loops here in this graph? We have only 2 loops. You can see the definition. Any edge that starts and end at the same vertex. So A and D. A and D. So we have 2 loops. So we remove. And step number 1 is remove the loop. Step number 2, remove all parallel edges between 2 vertices, except the one which least weight. We have to remove all parallel edges but you have to keep the least weight edge. Least weight means having the less number, having the less weight. So how many parallel edges here? Yes. Yes. Only one, A to C. Like we have two here, 2 and 12. See, we call parallel edges. We call parallel edges. Yes, this is parallel edges. So we have to keep one. Note in this graph, vertex A and C are connected by two parallel edges, having weight 2 and 12 respectively. So we will remove 12 and keep 2. And keep 2. Very simple. And keep 2. Okay, now understand. Step number 1, remove loop. Step number 2, remove parallel edges. Okay, we have to keep 2 only. Okay. So now we ready to find the MST, minimum steering tree. Okay. Remove all the loops and then remove the parallel edge. We will keep 2 and remove the 12 from A to C. And now we will find the MST. You can draw this in separate paper. So step number 3. Step 3 is you have to create the edge table. You have to create the edge table. What is edge table? Very simple. Edge table will have name of all the edges along with their weights is called, and it should be in ascending order. So how many weights we have? How many weights we have? Now if you look at the graph, that you notice there we have 5 edges. 5 edges. 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. We have 5 edge. 1, 2, 3, 4, 5. Okay. Okay. Edge and weight. You have to draw the table for edge and weight. Now look at the graph and fill the first column with the edge of minimum weight. Okay, the minimum weight is, in this case, B to C. B to C is 1. B to C is 1. So we select it. BC, and the weight is 1. Okay. Now look the graph again and find the next minimum weight, which is how many? In this case, we have A to B and A to C having 2. So we will select both of them. A to B and A to C. Okay, so in this case, we have 2 or more edges with same weight, then we can write them in any order, no issue. Either A to C or A to B or A to B or A to C. Any order. Tada masala. Okay. AB2 or AC2. Now look at the graph again. Then we have 3 number, C to D. And then last but not least, next is 5, which is BD. Okay, this is step number 3. So time to find, now the time to find the minimum spanning tree. How we find minimum spanning tree? Okay. Note that our graph have 4 vertices, 1, 2, 3. So our MST will have 3 edges. So it means that if we have 4 graph, your MST must be uh, 4 minus 1, which is 3. Okay. This is the rule basically. Okay. So how we'll proceed with this? To find the MST, we will start from the smallest weight edge and keep selecting edges that does not form any circuit. Circuit mean loop, we can say, with previously selected edge. There is no link with the previously selected edges. How? Here. 1 is the smallest weight. So we will select edge B, C. Edge B and C, this one. We highlight this. B and C. B and C, okay. Pastu, we have the second one, which is AB. So 2 is the next smallest weight and edge AB does not form a circuit with the previous selected edge. So we can select it. Because see, BC is different and AB is also different. There's no circuit like same edge, okay, it's different, okay. There's no circuit form. So we select AB like this. AC, next AC is the smallest weight, okay, we understand. But if we select AC, it will form a circuit. It will form a circuit. If we select AC, our circuit will complete. Understand? It will complete. For example, loop. So we can say loop, or we can say cycle, start and end will be interconnected. So we reject it like this. If we use, it will create a circuit. So next, DC. If we yes. So next is the DC. It does not form a circuit with the previous selected edge. So we'll select it. Yes. So we have got 3 edges. So we stop here because total number is 4. We got 3. Finish. So our graph has 4 vertices and our MST will have 3 edges. Always -1. Therefore, our required spanning tree is this one. Understand? Very, very simple. This we call Kruskal algorithm. Kruskal algorithm. So I already shared the link with you. You can do this. You can practice this again. Or first, what we have done, we remove the loops. Then we remove the parallel edge. Then we write a table, the edge table, okay, the or weight table, edge and weight, and then we have to go for MST. And in MST, we have to see whether the link will form a circuit or not. If it form a circuit, we will reject it. If no circuit, we will accept it. And one thing more, the last thing and very important thing, that if you have 4 edges or 4 vertices, for example, 4 vertices, so your MST will be 4 minus 1. It means 3. Understand? Yes.
Yes.
Okay, so very easy. We can proceed with the next algorithm. No need to go for further. So next week, I will complete three more, and then we have only one or two. So we have still 1 week more. Week number 12, 13, and 14 week also, because our test will be, I will decide the time and date of the test. But if you are okay with the time, like night time, okay, after Maghrib, 8 to 10, okay, 8 to 10. Understand? So your test will be at evening time, like after Maghrib, 8 to 10. So there is no excuse. So I will decide this maybe after Monday, not Monday, because Monday already taken by someone. So I will check it by today. Okay. I will get back to you tomorrow morning. I will give you the exact date and time. Time will be 8 to 10. This is finalized. Okay. And week number 14 done, but not Monday. Other than Monday, maybe Tuesday, Wednesday. Okay. Because I don't want, we have a lot of different tests. Some are engaged with other lecturers. So only the suitable time is 8 to 10. So let me decide by today, and I will get back to you tomorrow early morning. Okay. Okay. Thank you very much. So I don't want to linger on and go further because it's enough. We have only 4 or 5 algorithms like this. Very simple, very easy. Uh, I will share more videos. Next is the Prim's algorithm. Very, very easy. And then we have register algorithm, register 1 and register 2. And we will complete 3 algorithms by next week, and then 2 more algorithms by further, inshallah. Okay, thank you very much, and assalamu alaikum wa rahmatullahi wa barakatuh.
Waalaikumsalam. Thank you, Doctor.
Okay. Uh,
Thank you, Doctor.
You doctor.